Hello, my dear students of BSc first semester. Our next topic is average. We have done in the previous lecture average power in a forced mechanical oscillator. Now we will vary this power with the driving force frequency, as we have done in the previous lecture. Variation of phase difference with driving force frequency, variation of that is velocity, acceleration and displacement with the driving force frequency. Now we will discuss variation of average power with the driving force frequency, and also the very short topic, that is energy dissipated over one cycle. Clear? So we have done in the previous lecture that average power P average, that is equal to F naught square over 2 Zm cos phi, where cos phi is the power factor, and when it is 1, the power supplied to the oscillator is maximum. Here when it is 1. So now we want to vary this with omega. So same process we have when omega approaches to first case, when omega approaches to 0. So when omega approaches to 0, now we have to find out the value of Zm. And Zm is also in cos phi. How in cos phi? First we will find out the value of cos phi. We know tan phi is equal to m omega minus s over omega upon r. This is our tan phi. This is tan phi, and tan phi in a right angle triangle, the tan phi will be, if this angle is phi, then tan phi will be, this will be m omega minus s over omega, and this will be r. Clear? And this will be Zm, that is equal to under root of r square plus m omega minus s over omega whole square. Clear? So from this triangle A, B, C, you can find out cos phi. Cos phi will be base over hypotenuse. So cos phi, that will be r upon, this is equal to Zm na? Zm equal to, so r upon Zm. This is equal to cos phi. Here r upon this value, this is Zm. So you can put here. So average power becomes F naught square over 2 Zm into r by Zm, and that is equal to F naught square r over 2 Zm square when you put the value of cos phi. Clear? So now we have to vary this average power with omega. So same process, first case first, when omega approaches to 0. When omega approaches to 0. Yes, when omega approaches to 0, we have, because this value depend upon Zm, and Zm is equal to under root of r square plus m omega minus s over omega whole square. Clear ji? When omega approaches to 0, which term will dominate? We take r small as compared to this, as we have done in the previous lectures. So when omega approaches to 0, which term will be dominating? S over omega will be dominating term. So S over omega will be dominating term. So Zm is approximate equal to S over omega whole square, that is equal to S over omega. Here Zm is equal to S over omega, and when omega approaches to 0, this becomes, Zm becomes infinity. Zm square also becomes infinity. So when we put Zm approaches to infinity, average power, because here is Zm, infinity means 1 by 0. So when we put Zm infinity means 1 by 0, then average power approaches to 0. Clear? So when this implies average power approaches to 0 when omega approaches to 0. So this is the first case. Now the second case, when omega approaches to highest value infinity. Yes, bacha, when omega approaches to infinity, then what about Zm? In Zm, which term will be dominating now? M omega. So Zm is approximate equal to m omega. Clear? M omega square, m omega and infinity. When we put infinity, This is approximate also approaches to infinity. When it again approaches to infinity, we put here Zm infinity means 1 by 0, 1, 0 outside. So P average then again becomes 0. So again average power approaches to 0. Clear ji? And case third, when omega approaches to under root s over m. What is under root s over m? Angular frequency for undamped mechanical oscillator. Undamped mechanical, because we are doing forced mechanical oscillator. Yes. Yes, bache, when you put omega is equal to under root s over m. Here put omega is equal to under root s over m. So when you put omega is equal to m omega minus s over omega. When you put omega is under root s over m into under root s over omega, s over m, here minus s over omega under root s over m. Clear? It becomes under root sm, it becomes under root sm. Clear? Minus, yes, 1 minus 1 by 2. This m becomes upwards, and 1 minus 1 by this is also under root s over sm, and this is equal to 0. This is equal to 0. So this term will be equal to 0 now. M omega minus s over omega. So it implies if this term is 0, this term is not, this is very small but not equal to 0. I have also told you in the previous lecture. So this Zm approaches to now R. Zm R square under root goes, Zm approaches to R. If Zm is R, put here Zm R, then average power, I will write here because this is very important. So when omega approaches to under root s over m, Zm approaches to R, then average power, this is case third, average power is equal to F naught or approaches to R over 2 R square. So F naught square over 2 R. F naught square over 2 R. So we have three cases. Now the next step is to plot a graph. The next step is to plot a graph. So the graph between this, the graph between omega and average power. Very important graph. This graph will also be same like the graph we have done in the velocity, with variation of velocity with the driving force frequency. Okay? So first beta, when omega approaches to 0 and omega approaches to infinity, average power approaches to 0. So this is 0 point, this is 0 point. Clear? And next, it is maximum value. The average power is having maximum value. Where maximum value? At omega is equal to under root s over m. So this point is under root s over m. So when we join these points, this graph is very symmetrical. But take care. Clear? So this length up to this and this is f naught square upon 2r. The maximum power. Here is the maximum power. And when is the maximum power? When Zm approaches to r. Because we know cos phi, we have done cos phi is equal to r over Zm. When Zm approaches to 0, this is equal to 1. That's why I said in starting that ki cos phi power factor will be 1 when maximum power, when there is a maximum power. So when cos phi is 1, the average power is maximum. The maximum power is supplied to an oscillator. So maximum power supplied to an oscillator is f naught square over 2r. So this curve is also symmetrical curve, normal distribution like curve here, because an asymptotic to x-axis, doesn't touch its x-axis but very close to x-axis. So this is the maximum power supplied to an oscillator at frequency omega is equal to under root s over m. So that's why sometimes this velocity is called resonance frequency. Yeah. Then is energy. Next topic is energy dissipated. Yes. Now I rub this. Energy dissipated. Yes. This is a very short topic of 2 or 3 lines. I will explain. Energy dissipated. Yes. Energy dissipated over one cycle. Energy, because we have find average power over one cycle. Energy dissipated over one cycle. Energy dissipated over one cycle or over one time period. That is equal to energy dissipated, that is equal to average power into T. Average power into T. And average power that we have done F0 square upon 2 Zm cos phi into T. And that is equal to F0 square over 2 Zm R over Zm into T. This is energy dissipated. I write ED. Multiply and divide it by omega square. So we multiply and divide it by omega square. So this is equal to F0 square R over 2 Zm square into omega square T divided by omega square. Clear G? And what about omega square into T? We know that omega is equal to 2 pi over T. Omega square is equal to 2 pi over omega is equal to 2 pi over T. We know that. We write omega T from this omega T, that is equal to 2 pi. So we write here, this is omega square, we write it omega into omega. Omega into omega. So we put omega T is equal to 2 pi. So put here, this is equal to, I write, add here, sorry, I write here. So this will be, yes, energy dissipated. This is equal to F0 square R over 2 Zm square into omega into 2 pi. Omega T is 2 pi over omega square. Clear? And put the value of omega square. Now, yes, not put the value of omega square. I write it omega F0 square, F0 over, this is also square, this is also square, this is also square. So we can write F0 over omega Zm whole square. Can I write this like this? F0 square over 2 Zm. Yes. This 2 goes with this 2. This 2 goes with this 2. We have omega R pi. Pi R omega. And what is this? Yes, bache. What is this? This is displacement amplitude. This is because we have we know that x is equal to F0 over omega Zm sine of omega t minus phi. So from this is displacement amplitude. Clear? So we write it amplitude x a pi r omega square E energy dissipated. So energy dissipated is directly proportional to x a square, or sometimes it is also right x is a amplitude. So ED is directly proportional to amplitude square. Here, so where you can write xa is displacement amplitude. Sometimes it is also called only amplitude. So energy dissipated over one cycle. Energy dissipated over one cycle. That's why I write multiply it by T. So energy dissipated over one cycle over one time period is directly proportional to amplitude square. Is directly proportional to amplitude square. So thank you very much.